Okay, so we're here just looking at activity 32, which is your perfect competition practice number 1, and I'm just going to go through how to fill this chart in. My suggestion is that if you haven't filled the chart in yet, that you go ahead and stop this video, go back and give it a try. You have all the information that you need. This is just so that you can verify that you have the answers correct. So we're going to start with the easiest one, and that is your fixed cost. So by definition, fixed costs don't change. Therefore, for your third unit of input, your fixed cost is going to be $60, and that is going to remain the same through your 10 units of input. They give you your variable costs, so to get your total cost, you have to add your fixed cost plus your variable cost. At 3 units, it would be 180, and so forth. Okay, so once you've got your total cost filled in, we can take a look at marginal costs. In order to get our marginal costs, what we're doing is looking at the difference between levels of total cost. So the difference between 60 and 105 is a marginal cost of 45. The difference from 105 to 145 is a difference in cost of 40, or a marginal cost of 40. So then what you'll do is just calculate the difference all the way down between each of the levels of total cost. Once you've got your marginal cost column filled in, you may notice that the marginal cost curve decreases, hits a minimum, and then increases again. So here's our portion. Let me change the color here. This would be our portion where we're looking at diminishing returns. And this would be the portion where we're looking at increasing costs. So altogether, if we were to graph that out, we get that hallmark sort of Nike swoosh looking curve. That's why the numbers look the way they do. So then what we need to do is figure out our average fixed cost. For average fixed cost, you're just taking your fixed cost, which are 60 all the way down, dividing it by your levels of output. So for the next level, we take 60 divided by 3, and so our average fixed cost would be 20. If you increase the same, or if you take the same number and divide it by increasing numbers, you're going to get a continually smaller number. So average fixed cost starts at $60 and goes all the way down to $6. And so that would be that hallmark decreasing average fixed cost curve. For average variable cost, you'll take your variable cost, divide it by your level of output. So again, with the average variable cost, we see a portion of decreasing returns, diminishing returns, until we hit a minimum point, and then we see increasing again. So your average variable cost curve is that sort of U-shaped curve on the cost of production for perfect competition that falls just below average total cost. It would be the difference, the difference of the average fixed cost, which would be this downward sloping curve, is equal to the distance between your average variable cost and your average total cost on that graph. In order to find your average total cost, you simply take total cost, divide by your output. And for average total cost, once again, we have this portion of the curve that is decreasing or diminishing. So down here to 47.1, and then we have this period of increasing returns again. So once you have a completed table, it should look like that, and then you should be able to answer the questions that come next. So for the questions at the bottom of the page, I talked a little bit about these as we went through the numbers. The first question says, what happens to average fixed cost as output rises? We know that average fixed cost is a fixed number divided by increasingly larger numbers. And so if we were to graph that out, it would look something like this, just a steadily declining curve. The reason why that happens, again, is because you're taking a fixed number and you're dividing it by increasingly larger numbers. The second one says, what happens to average variable cost as output rises? So we said your average variable costs go down, they hit a minimum, and then they increase again. The reason for that, again, we said was the law, I'm going to write it up here, law of diminishing returns. So there's a point at the beginning of production where your costs go down, your output goes up, and then eventually the opposite will happen. Adding more resources to your production will result in declining production. Next question, what happens to ATC as output rises? Again, those numbers decrease, they hit a minimum, and then they increase again. Same reason, law of diminishing returns. What happens to marginal cost as output rises? Well, we said it declines initially, hits a minimum, and then it will increase again. We also know that it intersects ATC and AVC at their minimum point because it's a marginal or a change in. And again, the reason it's shaped that way is because of the law of diminishing returns. And I just answered the next one for you. What unique point does marginal cost cross AVC and ATC? And again, that's going to be at that minimum point. And the last question is, why is MC, marginal cost, the same, whether computed from total cost or variable cost? Well, the answer is the only difference between total cost and variable cost is the fixed cost. Fixed cost stays the same. So you can calculate your change in from either or, because the only thing that's going to change each time is going to be the amount of your variable costs. Okay, so last portion of questions. At the top of part E, it says, define on this sheet the following terms: total revenue, marginal revenue, average revenue. So total revenue is exactly what it sounds like. It's the total amount of money that your business brings in. Marginal revenue is going to be the change in revenue as you add units of output. And then average revenue will be your total revenue divided by your output. So with those things in mind, let's take a look at this marginal revenue problem down here. So you've got a table here, and it shows you the price is $10. Remember, it's always a market price in perfect competition. Firms have to sell at that market price. It shows you the quantity that they sell at, and then their total revenue and marginal revenue. So in order to fill this in, we're going to look at our price times our quantity in order to get our total revenue. So we know that the price is $10, the quantity there is 4, so our total revenue at this level will be 40. Our marginal revenue is going to be the change in the total. So change from 10 to 20 would be 10, change from 20 to 30 would be 10, and a change from 30 to 40 would be 10. Hopefully you're seeing a pattern emerge here, and there's a reason why we're emphasizing that. So it says, what generalization can you make about price? Here, let's highlight that. And marginal revenue under perfect competition. Well, the generalization is that they're the same. We said when we looked at graphs that your price and your demand and your marginal revenue and average revenue are all going to be the same in perfect competition. And the reason is because the price is fixed. Number 2 asks, why doesn't the perfect competitor lower the price to sell more? Well, the reason is because there are so many other sellers selling at a higher price, it would be impossible for them to compete because they're selling something that has a very elastic demand, and if you lower your price when your demand is elastic, your revenue will go down, and you will eventually go out of business. Number 3, what determines the price at which a perfect competitor sells the product? And the answer there is that the market determines that. So the long run equilibrium determines what that market price is, and the market price in turn determines the total revenue and marginal revenue. So that's it for perfect competition practice number 1. If you've got further questions or need further explanation, please let me know. Have a great day.